everyone, this is Aisha and welcome to our 15th Kotlin tutorial, and in this tutorial I'll be talking about the bitwise operators in Kotlin programming language. Now the bitwise operators are actually used to perform the bit by bit operations. For example, in Kotlin programming language we have certain bitwise operators, like we have OR bitwise operator, we had ON AND bitwise operator, then we have XOR, and then we have the shifting operators which include the left shift operator, and then we have the right shift operator. But in Kotlin programming language these operators are not called like the regular operators, and you have to use the infix notation to call these operators. But like we had in Java these operators can be called directly, but in Kotlin you have to use the infix notation, which we will discuss in the later section. But now in this tutorial I will simply use these bit by bit operations, and you will see that how these operators work. And for the infix notation, this is some internal working of the Kotlin programming language which we will discuss in the later section. Now here I have created two variables of integer type, a and b, and a contains 5, and in binary 5 equals 101, and b contains 4, and in binary 4 is 100. Now I am going to use the AND bitwise operator first. So I will write print line, and I will simply write a and then and b. So now this AND is a bitwise operator which will result. So what is the result of this AND operator and what it will result? It will give you. This is not any logical operator or any relational operator which results in either true or false, but it will give you a value. So when you use a and b, we will have 1 1 same bits, we will have 1, 0 0 same bits, okay, 0 0 we will have 0, 1 0 we will have 0. So a and b means this AND will result in 1 when both of the bits are 1, and if any of the bit is 0, the result of this AND bitwise operator will be 0. So when we have 1 1 we have 1, when we have 0 0 we have 0, when we have 0 1 we have again 0. So this AND operator will result in 1 if both of the bits of the operands are 1. So now 100 equals 4 in decimal number, so we will have 4 printed on our outer screen. You can see here 4 is printed. This is because 1 1 1 0 0 0 and 0 1 equals again 0. So 100 is 4 in decimal number. Now we will use the OR bitwise operator, and to use this OR bitwise operator you will write OR a or b. So it means that if both of the bits are 1, the result is 1. If both of the bits are 0, the result is 0. If any of the bit is 1, the result will 1. So the result will only be false when both of these bits are 0, and if any of these bits is 1, we will have 1 on the output. Debug, and you can see 101 equals 5, and you can see 5 is printed. Now we have XOR operator. So what is the purpose of this XOR operator? This XOR operator will result in 1 when these bits are different. So 1 1 same bit, we will have 0, 0 0 same bits, we will have 0, 1 0 different bits, we will have 1. So XOR result in 1 if both of the bits are different, and if the bits are same, the result of this XOR operator will be 0. Now debug, and you will have 1 on the output screen. And you can see here 1 is printed. Now we have the shifting operators, shifting bitwise operators. So these shifting operators are used to shift some bits to either left side or right side by specified number of bits, and these specified number of bits are given by the user. For example, let's talk about the left shift. So for using this left shift you have to use SHAL, and you have left shift. Now what this left shift will do, it will shift bits of the operand to the left side by specified number of times. If I write here 2 for example, then the value of a, which is 5, and in binary 5 equals 101, will be shifted to the left side by 2 bits, and then we will have 0 added to this right side. So when 1 is shifted, 0 is shifted, 1 again shifted, and then we will have two zeros. So 101 left shift equals 1 is shifted to the left side, 0 is shifted to the left side, and again 1 is shifted, and then two zeros will be added. Now this number is equal to 20 in decimal numbers. Now debug. So we will have 20 on the output screen. You can see here 20 is printed. So this is the left shift operator. Now we are going to use the right shift operator, and for the right shift operator you have to write S, then H, and then R. Now this will do what this will do, it will shift the bits to the right side by a specified number of times, and then it will add zeros to the left side. Like in the left shift we have added zeros to the right side, but in this shift we will have zeros on the left side. Now 1 is shifted, 0 is shifted, and 1 is shifted. So we will have two zeros on the right side, on the left side, and then 1 is eliminated, 0 is eliminated, and we are left with only 1. Now run debug, and you will have 1 on the output stream. You can see here 1 is printed. Now, so what we did in this tutorial, we have talked about these bitwise operators, which are OR, we have XOR, we have AND operator, we have shifting operators which contains left shift and the right shift. So thank you guys for watching the video, and I'll see you in the next tutorial.